may not seem like one of those anniversary years that you really celebrate, like 10 or 25 or 50. But each year when we ask national competitors what their favorite number is, the most popular answer has been 42. The answer to life, the universe, and everything. And for those of you that are feeling a little out of the know, that's a reference to Hitchhiker's Guide to the Galaxy. So we are doing up this milestone of 42 years for Math Counts and celebrating the 1980s when Math Counts started. Since we held the first Math Counts National Competition here in DC in 1984, we have celebrated the nation's brightest young minds through the only in-person math competition of its kind. In our 42nd year, we're celebrating your journey along this pathway, a journey marked by problem-solving skills, creativity, and persistence. You inspire us, and you make us proud. So while it could be argued 42 is the answer to a lot of things, we find comfort and hope in knowing that you will be the ones to find the answers to the most important and difficult challenges and opportunities that lie ahead for our society. So let's give all of you guys a round of applause. Now, to help lead today's program, we are fortunate to have some very special guests. They are Carrie Connors, a member of the Math Counts Board of Directors and the Executive Director of Global Affairs at RTX, the title sponsor of the national competition. Dr. Jagadish Pamalapati, the Deputy Assistant Secretary of Defense for Science and Technology Foundations. Latrinda Knighton, President of the National Council of Teachers and Mathematics. And coming to the stage now, Brian Malm, the President of the National Society of Professional Engineers.
I think that's the biggest ovation I'll get in my life. Thank you, Nancy. It is my great pleasure and honor to be here representing the National Society of Professional Engineers, one of the founding sponsors of Math Counts. What began in 1983 has grown to reach thousands of students each year in all 50 states and the District of Columbia, plus U.S. territories and overseas schools affiliated with the Department of Defense and the State Department. Mathletes, I know the path to nationals is a long one, including many months or even years of preparation and sustained success at the school, local, and state levels. Many people working behind the scenes or alongside you have supported you on this journey. And we'd like to take just a moment to recognize them for their contribution to making today's celebration possible. I'm especially excited to represent the thousands of licensed professional engineers who volunteer each year to coordinate and support in-person chapter and state competitions. Their commitment, expertise, and enthusiasm are remarkable, and I know they have inspired many future engineers. To those of you in the audience who are NSPE members, thank you for your dedication to these future engineers and for everything you do to promote and enhance our noble profession. Will all the members of NSPE please stand so we can recognize you? So I know we've got some seriously talented math minds in the room today, and if you're anything like I was at your age, not talented at math, but maybe somebody has already told you you should be an engineer someday. And they're right. Being good at math and science is a great start. Those skills are the foundation of what engineers do. But here's what they might not tell you. The real reason to become an engineer isn't just because you're good at solving equations. It's because you want to solve problems that matter. As a licensed professional engineer, I get to be a part of building the systems that keep people safe. Clean water, reliable roads, safe buildings, and strong bridges. Things we all depend on every single day. And what makes that work meaningful is knowing that it's not about me, it's about serving others. Engineering is more than a career. It's a calling to protect the public and improve lives. And for those of us at NSPE, that's what being a professional engineer is all about. So wherever your math journey takes you next, keep aiming high, because your talent has the potential to make a real difference in the world. In addition to providing volunteer support and being a founding sponsor of Math Counts, NSPE is proud to continue its national sponsorship alongside other generous companies and foundations that share our passion for Math Counts mission. Please join me now in thanking the major sponsors that make Math Counts possible. So we have title sponsor RTX, title sponsor the U.S. Department of Defense, also known as DoD STEM, and national sponsors Northrop Grumman Foundation, the National Society of Professional Engineers, 3M Gives, the Texas Instruments Incorporated, and Art of Problem Solving. Math Counts is fortunate to receive funding from many other corporations, foundations, alumni, volunteers, and even families of mathletes across the country. We are so appreciative of the support these companies and individuals have made. Would the representatives of all of the sponsoring organizations of Math Counts please stand to be recognized? From volunteers to educators to program funders, Math Counts is a huge team effort. And speaking of teams, it's now time to recognize the great teamwork demonstrated by Mathletes during the written competition. The first awards of the morning will go to the top 10 teams based on yesterday's performance. I will now announce the teams 10 through 4. Coaches and students, if I call your state, please stand and be recognized. In 10th place, Virginia. In 9th place, New Jersey. In 8th place, Connecticut. In 7th place, Indiana. In 6th place, Florida. In 5th place, Oregon. And in 4th place, Utah. So congratulations to these teams. Now, Nancy, Carrie, and Jag are going to join me on the stage to present trophies to the top 3 teams. The mathletes and coach from each winning team should come on stage to receive their awards. This year's 3rd place team comes from the state of Washington. I forgot to read the team members, I apologize. Team members are Samik Agrawal, Vivan Mukherjee, William Shin, and Alexander Yang, and the coach is David Tui. The 2nd place team comes from the state of New York. Team members are Derek Chen, Victor Yang, Hanru Zhang, and Ryan Zhang, and the coach is Zach Boyd. And now the first place team, the winners of the team competition, each receiving a $2,000 college scholarship, is from the state of Massachusetts. Team members are Eric Huang, Shlok Mukund, Brandon Nee, Soham Samanta, and the coach is Josh Frost. Congratulations to the Massachusetts team for this outstanding achievement.
All right. Thank you, Brian, and thank you all for this opportunity to join you on the final day of this year's MathCounts National Competition. It's such an honor to participate in the MathCounts National Championship and to meet the young people destined to be tomorrow's STEM professionals. At the Department of Defense, we recognize that STEM is the future. And as you all know, there is no STEM without the M and mathematics. Today's world of technology moves fast, and the DoD invests in programs like MathCounts because they play an integral role in preparing young people for studying STEM in college and building their STEM careers. I also would like to encourage everyone here to visit the DoD STEM site. That's dodstem.us, where you can learn about all the other many opportunities that the DoD has to offer, ranging from summer camps, special events, scholarships, and internships. Our labs employ a large number of science engineers and other STEM professionals who have some of the coolest jobs in the world. Their mission is to solve tough problems, invent amazing things, and keep our country safe. I have a good authority that there are a few of our MathCounts alumni that are building their careers within the department today. And so we are thrilled that this event and the MathCounts competition can lead to that pathway. Before we move to recognizing the individual achievements of some of our mathletes, we want to recognize one more team accomplishment. As you can imagine, the Department of Defense values teamwork and understands the importance of constantly striving for improvement. We also value when students push the limits and try to reach their maximum potential. And it's with that in mind that I'm extremely honored to announce our Most Improved Team Award this year. This award is given to the team that demonstrated the greatest improvement this year compared to states ranked over the last 10 years at nationals. I would like to ask the team members and a coach of this year's Most Improved Team to join me on stage, and that is a team from the state of Utah. And the team members from Utah are Adam Dang, Ashita Mandawal, Leo Shen, and Jonathan Wu, and our coach is Todd Vaudry. Congratulations, Utah, taking us through the net. Congratulations again, Utah. And now, taking us through the next portion of our event, please welcome Latrundra Knighton, President of MathCounts, founding sponsor, and the National Council of Teachers of Mathematics.
Thank you, Jag, and congratulations to our top teams. I am honored to represent the National Council of Teachers of Mathematics at this incredible event, and to do so in front of not only so many accomplished student mathematicians, but also so many dedicated, inspiring, and accomplished math educators. Math is especially powerful when it's relevant to students' lives and pushes them out of their comfort zone. Fortunately, MathCounts has incredible math experts who volunteer their time to write creative and complex problems that provide a fun and fulfilling challenge, the kind of productive struggle that makes success all the more meaningful. The unique math problems are a huge part of what makes MathCounts special, and I'm proud that many of the question writers, reviewers, and judges are associated with the National Council of Teachers of Mathematics. A couple of these volunteers are here this morning. Please stand so we can recognize and thank you. Thanks again. Now we are ready to announce the 12 truly outstanding problem solvers who excelled on yesterday's written competition and have qualified for a spot in this morning's countdown round. Are you ready? No. Okay. Competitors, just listen to a couple of directions first. If your name is called, please leave your calculators, hats, name badges, and any personal items with your team members and come up to the stage area over here with your team members and your coach. You will be provided with pencils and scratch paper at the contestants' table. Okay, here we go. I will first announce countdown round competitors 12 through 5. The number 12 seed is Lucas Lee from North Carolina. Number 11 is Alexander Yang from Washington. Okay. Number 10 is Jason Bowe from California. Just a reminder, coaches, you should be coming up with your competitors, okay? Thank you. Number 9, Ryan Zhang from New York. Number 8 is Shlok Mukund from Massachusetts. Number 7 is Justin Kim from California. Number 6 is Victor Yang from New York. And the number 5 seed is Adwaith Zoshi from New Jersey. Our next 2 competitors, number 4 and number 3, will each receive a bye in the first round of the countdown round. The number 4 seed is Andrew Dew from Virginia. And number 3 is Brandon Nee from Massachusetts. I think there are a few more, right? Okay. This year's written competition runner-up, who also earns a bye in the countdown round, is Alexander Veronos from Connecticut. Please welcome Alexander and his coach, Kevin Landisman, to the stage. And this year's written competition champion, who receives a bye in the countdown round and is the recipient of a $2,500 college scholarship, is Nathan Liu from Texas. Please welcome Nathan and his coach, Sherry Perkin, to the stage. Congratulations, Nathan.
Congratulations to all of our competitors. In a short while, one of you will become the 2025 national champion and the recipient of the Donald G. Weinert $20,000 scholarship. I'm Carrie Connors, a member of the RTX team, a longtime partner of MathCounts. It's my great honor to be with you today, here from Massachusetts. Where's Team Massachusetts? This year, we're throwing it back to the 1980s, a decade of big ideas, bold innovation, and of course, some unforgettable music. But this theme is more than just a fun retro nod. 1983, the year MathCounts was founded, also marked a turning point in tech history. It was the year the modern internet began to take shape. That same spirit of curiosity and progress sparked this incredible program, which has since inspired generations of students to tackle big challenges with even bigger thinking. In that spirit, this year's competition honors the history of computer science and celebrates all of you, the brilliant young minds who will shape its future. At RTX, we embrace the saying, "We don't predict the future, we create it." And to give you a little perspective on that, it was an RTX engineer who sent the very first email via ARPANET, the precursor to the internet. You are one of just 224 national finalists, a remarkable achievement. You've put in the work, sharpened your thinking, and developed the kind of thinking this world needs. This competition marks an important step in your journey, and we can't wait to see where it leads. But first, the moment we've all been waiting for, the countdown round. To guide us through this fast-paced math showdown, I'm excited to introduce Julie Montoya, back by popular demand. Julie is a lead systems engineer at Raytheon, one of RTX's 3 businesses, along with Collins Aerospace and Pratt & Whitney. She's working on the space sensor going on board the next NASA Landsat satellite. You might have seen her on the Emmy Award-winning show Innovation Nation, explaining how our VIIRS weather sensor helps monitor the planet from space. Julie earned her bachelor's and master's degree in control systems from Washington University. Her passion for space engineering began during her 2 internships at NASA, where she got hands-on experience with the same kind of math problems you're solving today. And yes, just like many of you, Julie competed in math competitions growing up and was the captain of her middle and high school math teams. She understands exactly what this moment means for you, and she's excited to cheer you on. So without further ado, give a warm welcome to Julie Montoya.
Thank you, Carrie. I'm excited to be back for my 4th year hosting. This is always one of my favorite events of the year. The world can sometimes feel like a very chaotic place, but luckily for us, I've always felt like math has this magical ability to bring order to chaos. So I thought I'd keep it simple in my speech this year and just tell you guys some of the really cool ways I've used math in my job lately. Landsat has a scanning mirror inside of it that moves back and forth every 7.5 seconds or so at varying speeds. We know the velocity we need to be at every point in the scan, so we took a derivative of the velocity function to get to acceleration. From there, we used the good old physics truth of force equals mass times acceleration to come up with a force output to the mirror to tell our motor vendor how powerful the motor we'd need, and our spacecraft provider how rocky that mirror motion might get in the system. Understanding how much contamination will end up on our optics in space is important for predicting how good our camera will be. We found a bunch of data on contamination from other space cameras and made a plot of contamination versus wavelength. We fit a curve to the data and extrapolated the curve out to the wavelengths we cared about and gave NASA an estimate of where we thought we might be. Once a month on orbit, Landsat, who usually points down at Earth, will have to do a backflip and take pictures of the moon instead for calibration. Knowing the orbital geometry of where the moon will be on a specific date and the altitude Landsat will be traveling at, we drew a triangle and used some trigonometry to calculate the magnitude of the backflip we'd need and how long the whole thing would take to help NASA's mission planners get it all into the mission timeline correctly. Now, my favorite one. Landsat collects data from a bunch of different wavelength bands. We had to order the bands precisely inside the camera to optimize the performance of all of them. My boss gave me the list of bands and a criteria for ordering them, and suddenly I had my very own operations research optimization problem to solve. I think that's why I love math so much. If you work hard enough, the answer's there. The optimal solution can be found no matter how hard the problem. You just have to look. There's been a Landsat on orbit for the last 50 years, gathering data for environmental data records and using math to contribute to our knowledge of this planet. I'm happy to do my part right now, and I hope one day I can welcome some of you to the team to keep that important math up in space far into the future. In a world full of chaos, I hope you'll seek out jobs like that, where you can use your math skills to help solve problems, build helpful things, and maybe make the world a better, less chaotic place. A round of applause for all of you this year. At this time, I'd like to welcome to the stage our 12 countdown round participants. Let's have a round of applause for all of them as we get a group photo. All right, now let's get right to it. The countdown round competition is a single elimination bracket tournament where the top 4 seeds will have a bye in the first round. I will read a question while it's being projected on the monitor in front of the students and also on a large screen for the audience. Should I misspeak when reading a problem, the problem showing on the student's monitor and the audience screen will be considered the official problem. Students will have 45 seconds to solve the problem after it appears on the monitor. There will be a green 45-second timer bar visible at the top of your screen. The timer bar will change to yellow when there are 10 seconds remaining on the clock. Competitors, once you've solved the problem, press your buzzer. This is very important. Don't just call out the answer. I will call on the first person who presses the buzzer to announce their answer. Do not announce your answer until I've called on you. If you answer without buzzing, your answer will not be recognized until you buzz in. Once I call on you, you will have 3 seconds to complete your answer. Your opponent may continue working while you're answering the question. If you answer incorrectly, your opponent will have the remainder of the 45 seconds to buzz in and answer the question. Whoever answers the most out of 5 questions correctly, not necessarily 3 out of 5, will win the round and progress to the next round. Should the score be tied after 5 questions, we will begin the sudden victory procedure, meaning the next student to answer a question correctly in the matchup will win the matchup. Good luck to each of you. And now, let's get on with the first matchup. All right, the first pair of students to compete will be our 8th and 9th place finalists as announced earlier. Shlok Mukund and Ryan Zhang, head to the stage, please. All right, we're going to give our competitors an opportunity to get used to their microphones by introducing themselves. Shlok, please tell everyone your school and what grade you're in. Oh, all right, yeah.
I'm in Jonas Clark Middle School in Massachusetts, and I'm in 7th grade.
Excellent. All right, now you said the thing you were most excited for at the national competition was the countdown round and the party. now that you're on stage for the countdown round, are you still having trouble deciding which one you're most excited for?
Probably the party.
Yeah. It's gonna be a good party. Yeah. All right, now you can go ahead and test your buzzer again. Give it another. There you go. All right, Ryan, go ahead and introduce yourself. Tell us what grade you're in and where you go to school.
I'm Ryan. I go to school at Jericho Middle School. I'm in 8th grade.
All right, Ryan, now you said you'd like to go back in time before famous mathematicians made their discoveries, so you could invent their results first. Yeah, it's a good one. If you could pick one result to be named after yourself, what would it be?
It'll probably be the Pythagorean theorem, because like everyone knows that one.
That's
So,
true.
like,
We could call it the Zhang theorem. All right, go ahead and test out your buzzer. Okay. Are you guys ready? Is the audience ready? Then let's get right to it. Question 1, and the question is, Cheapco Clothiers increases the price of a $90 suit by P%, while Glorious Garments discounts the price of a $210 suit by P%. As a result, the two suits now cost the same exact amount. What is the new price of each suit? Shlok.
$126.
That's the correct answer. Okay, off to a good start. Question 2, and the question is, square MNOP exists in the coordinate plane with vertices at M, 2, -4, N, P, 0, O, 2, 4, and P, Q, 0. What is the value of P plus Q? Shlok.
4.
That's the correct answer. 2-0 Shlok. All right, going to question 3 now. And the question is, what is the least, Ryan, time,
7.
I'm sorry. What is the least prime factor of 2020 squared minus 2019 squared? Shlok.
7.
That's the correct answer. End of the match. Shlok takes the round. Congratulations. All right, I'd like to welcome to the table our second round, Adwaith Zoshi and Lucas Lee. Gotta sit under your picture.
Oh my God.
All right, Adwaith, welcome back. Nice to see you again. Why don't you go ahead and introduce everyone, tell us where you go to school and what grade you're in.
I'm Adwait Zoshi from 7th grade in Heritage Middle School.
All right. Adwaith, you participate in a lot of different sports. Can you tell me which ones?
I do soccer and karate, and I swim once in a while.
Oh, well, that's a lot. Now, do your math skills help you with any of your athletic hobbies?
Yeah, like when I play soccer, I'm better at like judging where the ball goes than actually getting to the ball.
Yeah, there's a lot of angles in soccer. It's a great point. All right, go ahead and test out your buzzer. Nice. Okay, Lucas, go ahead and introduce yourself. Tell us what grade you're in and where you go to school.
My name is Lucas Lee. I'm in 8th grade and I go to Lake Nomenchodu.
All right, Lucas. Now, I heard you really enjoy mystery novels. Do you have a favorite book or author you can recommend to me?
I guess Sherlock Holmes.
Oh, yeah, I've heard of him, yeah. All right, go ahead and test out your buzzer. All right. Are you both ready? Then let's get into it. Question 1, and the question is, when Erica bikes from home to work at a speed of 24 miles per hour, she arrives at 9:26 a.m. Leaving home at the same time, if Erica bikes at a speed of 12 miles per hour, she arrives at 9:41 a.m. How many minutes will it take Erica to get to work if she bikes at a speed of 20 miles per hour? Adwaith.
Oh, 18.
All right, that's it. That's the correct answer. Buzzer beater. Just in the nick of time. Question 2, and the question is, one of the earliest number puzzles came from Aristotle. The goal was to place the integers 1 through 19 in the cells of the diagram shown, using each integer once so that the numbers Adwaith.
38.
That's the correct answer. And we're 2-0 Adwaith. All right, moving on to question 3. And the question is, if the measures of the interior angles, Adwaith.
Oh, 126.
That's time, and the incorrect answer. If the measures of an interior angles of a convex 9-sided polygon form an arithmetic sequence, what is the degree measure of the median of its interior angle measures? Lucas.
140.
140? That's the correct answer. All right, 2-1 going into question 4. And the question is, what is the least integer n greater than 1 such that the number of positive divisors of n is a perfect cube? Adwaith.
24.
That's the correct answer. And Adwaith takes the round. All right, at this time, I'd like to welcome to the table our third round competitors, Victor Yang and Alexander Yang. All right, Victor, welcome to the stage. Why don't you introduce yourself, tell us where you go to school and what grade you're in.
I'm Victor. I'm in 7th grade at Great Neck Forest Middle School.
All right, nice. Now, I really love your answer for your favorite number. You said my favorite number is 0 because it almost universally makes math easier. I guess unless you're dividing by it. If your favorite number is one that makes math universally easier, does that mean your least favorite number makes it harder?
I don't have a least favorite number.
You don't have a least favorite number. Well, that's good. You like them all equally, huh? Yeah?
Yeah.
All right, that's good. We'll find a good one for you. Go ahead and test your buzzer. All right. Now, Alexander, go ahead and introduce yourself. Tell us what grade you're in and where you go to school.
My name is Alexander Yang. I'm in 8th grade, and I go to Odell Middle School.
All right, nice job. Now, you use the internet to make a virus simulation for science class. What did you learn from your simulation?
How to use DeepSeek.
Is that the programming language?
Yeah.
Yeah, okay. Well, that's very useful. All right, good. All right, go ahead and test out your buzzer. Okay.
Wait, does the problem show up on this screen?
You will see them right there.
Okay.
Yep. Uh-huh. Okay. Are you guys ready? All right, let's get started. Question 1, and the question is, Alec chooses a random 5-digit... Alexander.
50.
I'm sorry, that's incorrect. Alec chooses a random 5-digit integer and squares it. What is the probability that his result has an even tens digit? Express your answer to the nearest percent. Victor.
90.
I'm sorry, that's also incorrect. We were looking for 80%. 80%. All right, still scoreless, going into question 2. And the question is, in square units, what is the area of the parallelogram with vertices at 7, 2, 1, 1, 0, 0, and 8, 3? Alexander.
21.
I'm sorry, that's incorrect. Victor.
8.
I'm sorry, that's also incorrect. We were looking for 5 this time. 5. We remain scoreless going into question 3.
Surely skip 0.
And the question is, a rectangular field measures 100 meters by 50 meters. Nick runs a lap around the exterior of the field so that he is always exactly 1 meter away. Victor.
303.
I'm sorry, that's incorrect. He is always exactly 1 meter away from the closest point on the perimeter of the field. How many meters long is Nick's lap? Express your answer to the nearest whole number. Alexander.
302.
I'm sorry, that's also incorrect. 306. Man, we're giving you guys the hard ones, huh? All right, building the tension, going into question 4, still scoreless. And the question is, what is the sum of all the real numbers x satisfying the quantity x squared minus 2x plus 5? Alexander.
9.
I'm sorry, that's incorrect. Raise to the power the quantity x squared minus 7x plus 12 equals 1.
7.
That is the correct
Yes.
answer, but as a reminder, wait till I call on you. All right, just as a reminder, wait till I call on you, all right? But you did good.
Okay.
Yeah. All right, question 5. And the question is, if n is a positive integer such that 2 raised to the n times n equals 32 raised to the 27th, Alexander.
128.
That's the correct answer.
Sudden death.
All right, as a reminder, we enter into our sudden victory procedure now. The next correct answer takes the match. And the question is, 2 distinct points are chosen uniformly at random. Alexander.
1/6.
I'm sorry, that's incorrect.
Oh.
At random on a circle, what is the probability that the length of a cord connecting them is less than the radius of Victor?
1/3.
That's the correct answer, and Victor takes the round. Whew, that was a good one. All right, at this time, I'd like to welcome to the stage our California battle, Justin Kim versus Jason Bowe. All right, hi there, Justin. Why don't you go ahead and introduce yourself, tell us what grade you're in and where you go to school.
I'm Justin. I'm in 7th grade and I go to Miller Middle School.
All right, now something unique about you is you have a very inconsistent sleep schedule. You live on the West Coast, so is being here on the East Coast making it even worse, or is the time change actually making it better?
I didn't get any sleep.
Oh. All right, well, that's all right. You're used to that. You'll do fine. You'll sleep well tonight. Go ahead and test out your buzzer. Okay, and Jason, go ahead and introduce yourself. Tell us what grade you're in and where you go to school.
Hi, I'm Jason. I'm in 7th grade and I go to Stratford.
All right, now Jason, one of your hobbies is gaming. Since we're celebrating the 80s, do you have any favorite retro games?
Does Pac-Man count?
Pac-Man totally counts, yeah.
It's the only one I know, so I guess it's my favorite.
As someone born in the 80s, I take issue with calling it retro. Go ahead and test out your buzzer. Excellent. All right, are you guys ready?
Yeah.
All right, we'll get right into it. Question 1, and the question is, in the addition problem shown, if A, B, C, and D each represent a distinct digit from 0 to 9 inclusive, what digit does A represent? Jason.
3.
That's the correct answer. All right, and we're 1-0 Jason going into question 2. And the question is, if the graphs of x squared plus y squared equals k and x, Jason.
50.
That's the correct answer.
I get it cooked.
And it is 2-0 Jason going into question 3. And the question is, Dave has 40 identical spherical solids, each of radius 2 centimeters. If he cuts each of them into 2 identical hemispheres, by what percentage will the total surface area of Dave's solids increase? Justin.
25.
I'm sorry, that's incorrect. Jason.
50.
That's the correct answer. And Jason takes the round. Now, this is the end of our first round matchups. The winners from these first 4 matchups will now compete against the top 4 seeds who had a bye in the previous round. The rules for the quarterfinals remain the same. So here we go. The first pair of students to compete will be Nathan Liu and Shlok Mukund. All right, Nathan, go ahead and introduce yourself. Tell us what grade you're in and where you go to school.
I'm in 8th grade and I go to St. Mark's School of Texas.
Okay, now, Nathan, you said one of the coolest things about the internet is you can use it to learn new things. What's the coolest thing the internet has helped you to learn?
I'm not really sure. I mean, I guess I rely heavily on the internet for math studying, but I mean.
For sure, yeah, there's a lot of good math on the internet. All right, go ahead and test out your buzzer for me. Nice, all right, and Shloke, give yours another try. All right, we got it. Are you guys ready? Yeah, okay. Question 1, and the question is, a pizzeria allows customers to create their own pizzas. Shloke.
192.
I'm sorry, that's incorrect. To start, customers must choose one of 3 sauces: green sauce, white sauce, or red sauce. Then they may choose up to 3 distinct toppings from 6 available toppings. How many different customer-created pizzas are possible? Nathan.
126.
That's the correct answer. Okay, question 2. And the question is, if x and y are real numbers such that x to the 4th equals y to the 4th, and 3x, Nathan.
20.
That's the correct answer. And we're at 2-0, Nathan, going into question 3. And the question is, what is the value of 51 cubed minus 49 cubed? Nathan.
15004.
I'm sorry, that's incorrect. Shloke.
750100.
I'm sorry, that's also incorrect. The correct answer is 15,002. All right, we keep it at 2-0 going into question 4. And the question is, if x equals 2025, Nathan.
2028.
Excellent, very good. Correct answer. And that's the end of the match. Nathan takes the round. All right, at this time, I'll welcome to the stage Andrew Dew and Adwaith Zoshi. All right, Andrew, go ahead and introduce yourself. Tell us what grade you're in and where you go to school.
I'm in 8th grade and I go to Cooper.
Okay. Andrew, you said you'd like to go back in time to the day of the first moon landing. I approve. Because it was an important day for space exploration. If you got to explore one place in outer space, where would it be?
Probably the sun, because it's the most important part of the solar system.
There's a lot of mysteries there to solve. That would be excellent. All right. Go ahead and test out your buzzer. Great. Adwaith, we know yours works. Good. Okay, are you guys ready? All right, let's get right into it. Question 1. And the question is, Penn is rolling an unfair 6-sided die. The faces are numbered. Adwaith.
1/7.
That's the correct answer. Okay, question 2. And the question is, the number of seconds in 6 weeks is equal to n factorial, where n is a positive integer. What is the value of n? Andrew.
10.
That's the correct answer. We're all tied up. Okay, question 3. And the question is, a particular rhombus has sides of length. Andrew.
60.
I'm sorry, that's incorrect. Sides of length 13 inches and diagonals of integer length. What is the area in square inches of the rhombus? Adwaith.
120.
That's the correct answer. And it's 2-1 Adwaith. All right, moving on to question 4. And the question is, for what value of x is 1 plus 1 over the quantity, 1 plus 1 over the... Andrew.
2/3.
That's the correct answer. And we're all tied up, headed into question 5. And the question is, what is the sum of all positive numbers g satisfying g cubed minus 28g raised to the 3/2 power equals, Andrew.
4.
I'm sorry, that's incorrect. Equals negative 27. Adwaith.
10.
That's the correct answer. Adwaith takes the round. All right, at this time, I'd like to welcome to the stage Brandon Nee and Victor Yang.
Wait, wrong.
All right, Brandon, go ahead and introduce yourself. Tell everyone where you go to school and what grade you're in.
Hi, I'm Brandon Nee. I'm in 7th grade and go to Jonas Clark Middle School in Lexington.
All right, now, Brandon, you said the 80s fashion trend you want to bring back is tracksuits. What does your ideal tracksuit look like?
I have no idea. I just was more in opposition against the other two, so I don't quite have an answer to this one.
What were the other two?
I don't remember.
Okay. All right. Well, tracksuits are very comfortable. It's a good pick. All right. Go ahead and test out your buzzer. Okay. And Victor, give your buzzer a try again. You got it. Okay. Are you guys ready?
Yeah.
All right. Let's get into it. Question 1. And the question is, what is the minimum number of times a fair coin must be flipped? Brandon.
6.
That's the correct answer. All right, we're at 1-0 Brandon, going into question 2. And the question is, if a and b are positive integers and 35 cubed times 7 raised to the a times 11 raised to the b has exactly 100. Brandon.
66.
I'm sorry, that's incorrect. Has exactly 100 positive divisors. What is the value of 10a plus b? Victor.
14.
That's the correct answer, and we're all tied up. Okay, going into question 3, and the question is, what is the least positive integer n? Brandon.
1.
I'm sorry, that's incorrect. What is the least positive integer n for which 2 to the n plus 2 to the 6th plus 2 to the 9th is a perfect square? Allowing?
8.
To the judges? Okay, Victor, and your answer is?
8.
That's the incorrect answer. That was a tough one. It's a 10. We were looking for 10.
Wow.
Oh, that's right.
All right, all tied up, headed into question 4. And the question is, in square units, what is the area of the region of overlap in the coordinate plane for x squared plus y squared is less than 100, and y is less than the absolute value of x minus 10? Express your answer in terms of pi. Brandon.
50 pi minus 100.
That's the correct answer. All right, moving into question 5. And the question is, a certain 12-hour clock chimes every hour on the hour, and the number of chimes at each hour is equal to the number of the hour. For example, the bell chimes 7 times at 7 p.m. and 12 times at midnight. How many times does the clock chime in 1 year? Express your answer to the nearest 1,000. Brandon.
5,000, 57,000. Oh. Wait.
To the judges are deliberating. Okay, that's an incorrect answer. All right, Victor?
48,000.
Also an incorrect answer. Looking for 57,000. I think you had it.
Oh my, I missed.
That was a tough one, but Brandon takes the round. All right, at this time, I'd like to welcome to the stage Alexanders Veronos and Jason Bowe. All right, Alexander, go ahead and introduce yourself. Tell us what grade you're in and where you go to school.
I'm in 7th grade, and I go to Brunswick Middle School.
Okay, now you like to solve problems while shooting hoops. What does that benefit more? Does it make the problems easier to solve or the shots easier to sink?
I don't know, like, just sometimes, like, makes me focus better.
Yeah? I think Michael Jordan did the same thing. All right, test out your buzzer. Okay, and Jason, make sure yours still works. Great. Okay, are you guys ready? We'll get right into it. Question 1, and the question is, what is the sum of all distinct real numbers x that satisfy x cubed? Alexander.
2.
That's the correct answer. Okay, question 2, and the question is, what is the value of the expression, the square root of 0.88? Alexander.
0.66.
I'm sorry, that's incorrect. 0.88 over 1.98. Express your answer as a decimal to the nearest hundredth. Jason.
0.67.
That's it. You were so close, Alexander. All right, all tied up, going into question 3. And the question is, in cubic units, what is the volume of the largest cube that can be inscribed in a hemisphere of radius 4? Express your answer as a common fraction in simplest radical form. Jason.
512 root 5 over 25.
I'm sorry, that's incorrect.
Okay.
And that's time. We were looking for 128 root 6 over 9.
Oh, I was going to get it, bro.
Just needed one more second, right? All right, all tied up, going into question 4. And the question is, how many positive integers less than 2025 are divisible by at least... Alexander.
105.
I'm sorry, that's incorrect. Divisible by at least one of the numbers 25 and 81. Jason.
104.
That's the correct answer. All right, going to question 5. And the question is, what is the remainder when 1 raised to the 0 plus 2 raised to the 10th plus 3 raised to the 20th? Alexander.
4.
That's the correct answer. And we're all tied up. All right, as a reminder, we will again enter our sudden victory procedure. So the next correct answer takes the match. Are you guys ready? All right, and the next question is, what is the negative value of x for which x minus 9 over x equals 7 minus 9 over 7? Express your answer as a comment. Alexander.
Negative 9 over 7.
That's the correct answer. Alex has got it. All right, that brings us to the end of this round. We now have reached the semifinals with only 4 students remaining with a chance to become the national champion. Now, before we find out who the national champion will be, We want to give each of the countdown round participants their moment to be recognized for their incredible accomplishments yesterday and today. Nancy, Carrie, and Jag will help present trophies to these amazing competitors and plaques to their coaches. Please join me in congratulating our first round countdown participants, Ryan Zhang and his coach, Zach Boyd. We're good? Okay, Lucas Lee and his coach, Teo Hong. All right, Alexander Yang and his coach, Wei Tui. And Justin Kim and his coach, Monica Manolescu. All right. And now join me in congratulating our countdown round quarterfinalists. Jason Bowe with his coach, Monica Manolescu. Shlok Mukund and his coach, Josh Frost. Andrew Dew and his coach, Lisa Walsh. And Victor Yang with his coach, Zach Boyd. And then there were 4. For the rest of the competition, our rules will change slightly. From this point on, to win a round, our mathletes will have to answer 4 questions correctly. And now, on to our first matchup of the semifinals. Nathan Liu and Adwaith Zoshi, please join us at the competitors table.
Lock in.
All right. Adwaith, you made it to the big time this year. You want to test out your buzzer? Okay, and Nathan? Excellent, still works. Let's get right into it. The first question, and the question is, A certain parallelogram with altitudes of lengths 2 centimeters and 3 centimeters has a perimeter 40 centimeters. Nathan.
24.
That's the correct answer. All right, and the next question is, what is the sum of the coefficients of the Nathan?
11.
That's the correct answer. All right, we have 2-0 Nathan. And the next question is, when the product of add wave.
15/2.
That is the correct answer. Holy moly.
And this.
All right, 2-1, going into the next question. And the question is, consider the list of all positive integers less than 10,000, whose digits, add wave.
8,888.
That's the correct answer. And we are all tied up. And the next question is, regular hexagon, COUNTS, is inscribed, Nathan.
3/4.
That's correct. All right, it's 3-2. And the next question is, Brent flips 3 fair coins. Add wave.
0.
That's the correct answer. Holy moly.
Lock in. Lock in. 1.
Oh my God.
This is a very exciting round. All right, the next point wins the matchup. And the next question is, what is the value of add wave?
Oh, oops. 1.
That's time,
point.
I'm sorry.
Okay.
What is the value of the expression 3.42 plus 1.75 squared minus the quantity 1.75 minus 3.42 squared? Express your answer as a decimal to the nearest hundredth. Nathan?
23.94.
That's the correct answer. Great matchup. All right, at this time, I'd like to welcome to the stage Alexander Zvronos and Brandon Nee. All right, are you guys excited?
Yeah.
This is
Yes.
it? You did it. Brandon, go ahead and test your buzzer. And Alexander. Okay, still work. Let's get right into it then. And the next question is, the functions f of x equals negative 2x plus 4 and g of x equals rx plus s have the property that f of g of x equals 6x plus 10 for all real numbers. What is the value? Brandon.
9.
That's the correct answer.
I got it the exact same time.
And the next question is, a circular pizza with radius 12 inches is divided into 12 congruent slices. Ben removes 2 slices and Rachel removes 3 slices. Brandon.
14 pi plus 24.
That's correct. All right, it's 2-0 going into the next question. And the question is, the sum of the digits of each of the 3-digit positive integers, x, y, and z, is 9, and x plus y equals z. What is the least possible value of z? Brandon.
216.
That's it. He's on a roll.
Horse.
All right, 3-0 Brandon, headed into the next question. And the question is, Alexander.
72.
That's the correct answer.
Wow.
Wowzer.
Let's go.
All right, 3-1. And the next question is, today is Monday. What day of the week will it be in 2025, raised to the 20th, raised to the 25th, days from today? Alexander.
2. What the fuck? Bro, I just mod 7. Oh, shit.
Tuesday.
Okay.
Brandon.
Wednesday.
I'm sorry, that's incorrect.
Ah.
Looking for Friday.
Ah.
Let's go.
And it is 3-1 Brandon, headed into the next question. And the question is, Miles runs the first kilometer of a 5K race at an average speed of 12 kilometers per hour. Brandon.
15/4.
I'm sorry, that's incorrect. He wants to have an overall average speed of 15 kilometers per hour for the entire race. At what average speed in kilometers per hour does he need to run the remaining 4 kilometers of the race? Alexander.
240 over 11.
I'm sorry, that's also incorrect.
Oh my, was it 16?
Looking for 16.
I accidentally I don't even know. Oh wait, I did for a minute.
Okay. And the next question is, in triangle ABC shown here, Alexander.
49 over 25.
That's correct.
Wow.
Let's go.
And the next question is, for each positive integer n, the product of the first n terms in a certain sequence is equal to Alexander?
6/5.
I'm sorry, that's incorrect.
No?
Equal to n times the quantity n plus 1 times the quantity n plus 2. What is the 15th term of the sequence? Express your answer as a common fraction. Brandon.
17/14.
That's it. Good round. Brandon takes the match. We are now in the final round of the competition. The winner of this round will be the 2025 national champion. The two students who will be competing for this honor are Nathan Liu and Brandon Nee. Let's give them a round of applause. You got this, guys. Everyone, take a deep breath. You're gonna do great. Okay, let's have you try out your buzzers. Brandon. Okay, and Nathan. Excellent. Are you guys ready? You look ready. And the question is, in the coordinate plane, a triangle is bounded by the lines y equals negative x plus 10, y equals 0, and y equals kx. If this triangle has, Nathan. That's time, sorry. If this triangle has area 15 units squared and k greater than 0, what is the value of k? Express your answer as a common fraction. Yeah, Brandon.
10/3.
I'm sorry, that's incorrect.
3/10.
I got stuck.
Wait,
The answer
3/7?
we're looking for is 3/7.
Oh, shoot, I'm stupid.
Let's take a second to make sure those buzzers still work. So, Brandon? Maybe we need a little buzzer adjustment. This one's not plugged into anything.
Huh?
I give you this one. Nathan, does yours work?
No.
Uh-oh.
Oh.
Wait, what?
Oh.
Brandon?
Oh.
We're back in action. Thanks, IT.
Yay. Buzzer.
All right, still scoreless, going into the next question. And the question is, Evan is twice as old as Devin was 7 years ago. Devin is twice as old as Kevin was 7 years ago. Kevin is twice as old as Evan was 7 years ago. How many years old is Devin? Brandon.
14.
That's it.
Oh wait, they're all the same age. Okay.
Nice.
Hindsight really tough. Good job. This
All right, and it's 1-0 Brandon, going into the next question. And the question is, Eden writes down a 5x5 multiplication table. Nathan.
6.
I'm sorry, that's incorrect. meaning she writes down the number a times b for each pair AB of integers, with 1 less than or equal to a less than or equal to 5, and 1 less than or equal to b less than or equal to 5. What is the mode of the 25 numbers Eden writes down? Brandon?
8.
Sorry, that's incorrect. We were looking for 4. 4.
Oh wait, I calculated median. I calculated median for some reason. I have no idea why.
All right, you guys are doing great. 1-0 headed into the next question. And the question is, the first term common to both arithmetic sequences, 1, 4, Brandon?
136.
That's the correct answer.
Holy.
All right, it's 2-0 Brandon going into the next question. And the question is, a fair coin is tossed 7 times. What is the probability that there is never a heads toss? Brandon?
1/64.
I'm sorry, that's incorrect. The probability that there is never a heads toss followed immediately by a tails toss any time during these 7 flips. Express your answer as a common fraction. Nathan?
1/16.
That's it. Okay, the score is 2-1, headed into the next question. And the question is, an acute triangle has sides of length p inches, q inches, and r inches. Brandon?
15.
I'm sorry, that's incorrect. For distinct primes p, q, and r, what is the least possible perimeter of this triangle in inches? Nathan?
31.
That's the correct answer. We're all tied up and building the tension in the final round. And the next question is, for how many integers n between 0 and 9 inclusive is the statement, there is a positive integer of the form 1 plus 2 plus 3 and so on plus k for some positive integer k whose units digit is n? Nathan?
6.
That's correct. All right, 3-2 Nathan. And the next question is, a regular octahedron has a surface area that is 44, Nathan?
1728.
That's it, that's the correct answer. All right, that means that Nathan Liu, you are our 2025 Math Counts RTX National Champion. to the stage to present trophies to our top mathletes. Please give a loud round of applause for our top 4 students in the 2025 National Countdown Round. Our 2 Countdown Round semifinalists, each of whom will receive a $3,000 college scholarship, are Adwaith Zoshi and Coach Claire Samuel. Come on up. And Alexander Sabronos and Coach Kevin Landisman. Come on up. A $7,500 college scholarship is Brandon Nee with Coach Josh Frost. Math Counts National Champion, the recipient of a $20,000 Dave Weinert College Scholarship, is Nathan Liu with Coach Sherry Perkins. Congratulations to all 224 of our mathletes. Give yourselves a round of applause. All right, this concludes our morning's program. We look forward to seeing many of you back here at 6 p.m. for that party we're hyping up tonight. Thank you.